Hi guys, here's the second video. I just wanted to explain the fall factor a bit more and draw the diagrams close up. So on the left, we've got the basic best case scenario in a lead fall. So you can see the belayer at the bottom, just here, and then the climber up here takes a 1 metre fall with 7 metres of rope out. So we have the length of the fall divided by the length of the rope in the system gives us a fall factor of 0.142. Okay, so standard lead fall. Here's the sort of textbook catastrophic factor 2 fall that they illustrate on all the websites. So it's a belayer on a ledge with some fall below them. The climber climbs without protection with 2 metres of rope out, but falls, and they fall 2 metres. So this is something that would be quite likely off a belay on a multi-pitch. Obviously, you need that extra 2 metres below. So we have 4 metres of fall and 2 metres of rope out, which equals a factor 2 fall. So 4 divided by 2 equals 2, and that is death. The harness will break at that point. So we now come to Mark's experience. And what we see here is a simulated Chockstone. This is Tim belaying, Mark calling for a tight rope at 4 metres. And then I've drawn in these 3 edges where the rope theoretically could angle over the edge. And this is the thing that increases the fall factor. Because if Mark gets up to here with the loop up, he has a 3 metre fall back to where he was. So 1, 2, 3, 4 at Tim, so 3 metre fall. But because of this edge acts to take the stretch out of the rope and through friction, which you'll recall when the rope goes over an edge, it can actually draw you to a stop. And this makes this 1 metre. So there's 1 metre of rope in the physics and 3 metres of fall. So it's 3 metres of fall with 1 metre of rope equals a factor 3. So it's certain harness failure if Mark falls up here. And this fall on this side is an order of 21 times worse than this lead fall over here. So that's explaining the physics that might have been involved in a fall with Mark. It's particularly this first edge that increases the fall factor, because as far as the physics on the rope are concerned, there's only 1 metre of rope out to take the fall, but there's 3 metres of energy that's gone into the fall before that 1 metre comes into action. And so that makes that a factor 3 fall. And you can see that it is worse than that, and this is certain harness failure. So I hope that explains that. And I'll just leave that picture up for a second so you can look at it and pause it. And I'll see you later.